Hello everyone, today we're going to look at graphing a sine of Bx plus C plus D and y equals a cosine Bx plus C plus D. So we have the following definitions, two of which we've already gone over. The amplitude, which is the absolute value of a. The period, which again is 2 pi over b if in radians and 360 degrees over b if in degrees. The frequency, again, is 1 over the period, so b over 2 pi or b over 360. The following two things are new. We have the vertical displacement, which is d, and we have the horizontal displacement, which is negative c over b. So these are the two new things that we're going to talk about in today's video. So d changes the y values in the following way. The main y values without vertical displacement, remember, are negative the amplitude, 0 and the amplitude. But with a vertical displacement, we're going to add d to each of those values. So our minimum is going to be the negative absolute value plus d. Our 0 is going to be d. And our maximum is going to be the amplitude plus d. So we're just adding d to all of these values that we had before. Negative c over b changes the x values. So each of the 5 main values that we had before, remember the minimums, maximums, and zeros, were at 0, the period divided by 4, the period divided by 2, 3 times the period divided by 4, and then the period. So now we're going to add the negative c over b to each of those values. So the d is going to be shifting the picture vertically, and the negative c over b is going to be shifting the picture horizontally. So let's try the following. We're going to start off the exact same way that we did in the previous video. So I have y equals cosine of 3x plus 2. We're going to graph it in degrees. So just like before, we're going to start with the amplitude and the period. So the amplitude is 1 because a is 1. The period is 360 degrees divided by our b, which is 3. So that's where we're getting the 120 degrees. The horizontal displacement is 0 because c is 0. And the vertical displacement is 2 because that's our d. So I'm going to have 3 rows in my table now instead of just the 2, the x and the y. I'm going to have x with a bs, which is for before shift. So these are the values that we would have had last class if there wasn't a horizontal displacement. And there isn't one in this example anyway, but I'm just going to have the graph set up the same way. So this still starts at 0, right? And again, it's in degrees, so it's 0 degrees. And then we're going to have a quarter of our period. So our period is 120 divided by 4, and that's going to give us 30 degrees. So we have 30 degrees, and then we have another 30 degrees, and then another 30 degrees, and then another 30 degrees. And that's going to give us our 120 degrees. Remember, it always ends at our period. So next, I would have x with an AS, so the after shift values. Again, we don't have a horizontal shift here, so our after shift values in this case are going to be the same as our before shift. And then we're going to have our y's. So here our y's are going to change. So again, before, our minimum was negative 1, our 0 was 0, and our maximum was 1. And these numbers all depended on the amplitude. But now I'm going to add 2 to each of those values. So my minimum is now going to be 1. My 0, in quotes, is going to be 2. And my maximum is going to be 3. So when I go through this, I look at the fact that I have a cosine. I say, okay, if I just draw a little sketch here, and I always do that, my cosine starts at my maximum. And then it's 0, minimum, 0, maximum. But those values have now changed. So again, my maximum is 3, excuse me, my 0 is 2, and my minimum is 1. So I'm going to fill those numbers into my table. So it starts at the maximum, goes down to what had been our 0 and is now our d, which is 2. goes down to our minimum, -1 plus 2, goes back up to our quote-unquote 0, which is 2, and ends at our maximum. So now when I go to graph it, I'm going to have not just the dashed lines for my minimum and maximum, but I'm also going to have one for my 0. So my main values are 1, 2, and 3. So I'm going to have a little dashed line for each of those. Right, so 1, 2, and 3. And I didn't really give myself enough room here, so bear with me. 30 degrees, 60 degrees. I don't know if you can see that. I'll put it up here, 90 degrees, and 120 degrees. So at 0 degrees, I'm at 3. At 30, I'm at 2. At 60, I'm at 1. At 90, I'm at 2. And at 120, I'm at 3. So we still have that same curve. That shape has not changed. We're just moving it. So it's still a very nice cosine curve here. Okay, so that D is just going to move it up or down. So now we're going to have a horizontal shift, but we're not going to have a vertical shift. So our amplitude is 2. Our period, 2 pi divided by 4, gives us pi over 2. Remember, we don't want to put decimals here. We want to keep it as a rational coefficient times pi. So pi over 2 or 1/2 pi. Our horizontal displacement is -c over b. So c is -2 pi. So -c over b, or -c is +2 pi, and b is 4. So our horizontal displacement is also pi over 2. And then our vertical displacement is 0 because we're not adding anything after the trig function. So our before shift values start at 0, and then we want a quarter of our period. So pi over 2 times a quarter gives us pi over 8. And then we're going to double it or take half of our period, which gives us pi over 4. Our next value, again, is 3 times this guy, so 3 pi over 8. Our last value is our period, pi over 2. So now we will have after shift values. So again, we're going to start with these numbers, and then we're going to add our horizontal displacement. So we're going to add pi over 2 to each of these guys. So our first value is 0 plus pi over 2, which is pi over 2. And then pi over 8 plus pi over 2 is 5 pi over 8. Remember, pi over 2 is 4 pi over 8. So pi over 8 plus 4 pi over 8 is 5 pi over 8. Pi over 4 plus pi over 2 gives me 3 pi over 4. 3 pi over 8 plus pi over 2 gives me 7 pi over 8. And then my last one is pi. So and you always want to check, if you don't feel great with fractions, always check that your numbers are A, in increasing order, and B, equidistant from each other. Right? Each of these numbers should be off by that pi over 4. So if I add pi over 8 to each of these numbers, I should be getting the next one. Next, we look at the y's. So again, we don't have a vertical shift, so we're just looking at our minimum of -2, our 0 at 0, and our maximum at 2. And we've got sine, so again, a very generic form of sine. Starts at 0, then the maximum, then 0, the minimum, and then 0 again. So 0, maximum is 2, 0, minimum is -2, and 0 again. And then we put it all together in our graph. So for our y values, we've got -2, whoops, -2, +2, and then we have to make sure that we're really showing this horizontal shift here. So pi over 2 is out here, and then the rest of them are fairly close to each other. you want to make sure that your number line makes sense, right? I'm not going to have, say, pi over 2 over here and then 5 pi over 8 over there. Okay, they're not going to be next to each other like that. Pi over 2 is really bringing it to the right further. I should even have made that distance between 0 and pi over 2 further apart. But just make sure that you can clearly see that there is a a horizontal shift in here. So then I start plotting them. So at pi over 2, my graph is at 0. 5 pi over 2, it's at 2, then 0, then negative 2, and then 0. So I connect them, and again I can see that it's shifted because I have this blank space over here. Right, so again, just make sure that I can clearly see the shift in the graph. I also want to see your table of values, right? Because I don't care if you can graph it, using a graphing calculator or using a computer. I want to see you plugging in the numbers. So make sure I see the work here. Okay, so let's try another one. So this one's going to have both shifts here. So we start, as always, with the amplitude and the period. So our amplitude is 1. Our period is going to be 4 pi, so it's in radians. So we want 2 pi divided by b, which is a half. So again, dividing by a fraction is multiplying by the reciprocal. The reciprocal of a half is 2. So 2 pi times 2 gives me the period of 4 pi. And then we've got a horizontal displacement of negative c over b. So negative c over b. So again, we're going to, instead of dividing by a half, we're going to multiply by 2. So that's how we get the negative pi over 2. And then the vertical displacement is again our d. So in this case, our d is negative, so we're going to be shifting it down. So we got our before shift values, starting at 0, and then a quarter of our period. So a quarter of 4 pi is just pi. So you have pi, then 2 pi, then 3 pi, and then 4 pi. And then we're going to take those numbers and we're going to subtract pi over 2 from each of them. So 0 minus pi over 2 is negative pi over 2. Pi over 2 minus pi minus pi over 2 is pi over 2. Then we get 3 pi over 2, 5 pi over 2, and 7 pi over 2. So again, my numbers are in increasing order, and they're increasing by this guy, so they're increasing by pi. For my y values, we got to be careful here. We've got two things going on. We've got a negative cosine, and we've got our vertical displacement. So before, our numbers were negative 1, 0, and 1. Those were our minimum, 0, and maximum. Now we're going to add a negative 1 to each of them. So we're going to get negative 2, negative 1, and 0. So my minimum is negative 2, my 0, in quotes, is negative 1, and my maximum is 0. Cosine starts at the maximum, but it's a negative cosine, so we're going to start at the minimum. So we start at negative 2. When we're at the minimum, we can only go up until we hit what had been our 0, which is now negative 1. Then we keep going up to our maximum, which is 0. Once we're at our maximum, we have to go down. So we go down to negative 1, and then down to negative 2. So to graph these guys, again, I'm going to graph my minimum, maximum, and my 0. So my maximum is now my 0, so I don't really need the dotted line there. But I will need it for my negative 1, which is now my 0, and my negative 2, which is my minimum. My first value is negative, so make sure that's on the correct side of your axes. Right, wherever I draw my axes, that determines where my origin is. I always have someone who will draw this and then they'll call this like negative pi. Don't do that, because when I draw my axes, that is 0, and that's not anything else but 0. So don't call that something else. Make sure you're putting your negative numbers to the left of that axis. Okay, so I got negative pi, and then I've got negative pi over 2, sorry. And then I've got pi over 2. And then I've got 3 pi over 2, 5 pi over 2, and I didn't quite draw this long enough, 7 pi over 2. So again, each of these numbers should be equidistant from each other. So that distance that I have between negative pi over 2 and pi over 2 should be the same distance that I have between pi over 2 and 3 pi over 2, which is the same distance between 3 pi over 2 and 5 pi over 2, and so on. All right, so again, just make sure that your number line makes sense. And then we'll graph it. So at negative pi over 2, I'm at my negative 2. At pi over 2, I'm at negative 1. Right, remember to skip over 0. 0 is not one of my points anymore, so I don't have a point on my y-axis. And 3 pi over 2 is 0. 5 pi over 2 is negative 1. 7 pi over 2 is negative 2. So we've got this upside down cosine curve. And again, just make sure it's a wave, it's a curve, you're not putting straight lines between your points. So let's try another one. Y equals 4 sine of 2/3 x minus 90 degrees plus 2 in degrees. Right, the fact that I have a degree sign there tells me it's in degrees anyway, but I'm just saying it again, it's in degrees. Our amplitude is 4. Our period is 540. So again, we're taking 360 dividing by 2/3, which is multiplying by the reciprocal. So I'm going to have 360 divided by 2 is 180. 180 times 3 gives me my 540. Okay, so dividing by 2/3 is multiplying by 3/2. Our horizontal displacement is negative c, so that's 90, and divided by b, so again we'll multiply by 3/2. Cancel a 2. 45 times 3 gives me my 135. My vertical displacement is again my constant at the end, which is 2. I start my table. I start at 0. Then I want a quarter of my period. So that gives me 135 degrees. And then I want either twice that or half of my period, which is 270. Then I want 3 times this guy. That's 405. And then lastly, I should be getting my 540 again. Then we start with our after shift values. So again, we're going to be adding 135 degrees to each of those angles. So we get 135 degrees, 270 degrees, 405, 540, and lastly 675. For our y values, we look at the fact that it's sine and that we're adding 2. So my minimums was negative 4, my 0 was 0, and my maximum was 4 based off of my amplitude. I'm going to add 2 to each of those values. So my new minimum is negative 2, my new 0 is 2, and my new maximum is 6. Sine starts at 0, so it's going to start at 2 and then move up. So 2 goes up to 6, goes back down to 2, goes down to my minimum of negative 2, and then goes back up to my 0, which is 2. So when I go to graph it, again, I'm going to keep those numbers in mind. So I have a negative 2 down here. I have a positive 2. And then I have a 6, which is not quite to scale there, but I'll try my best. And then we've got 135, 270, 405, 540, again kind of running out of room here, whoops, 675 degrees. And I want you to notice that they are all equally spaced, and in this case, even from 0 to 135 is equally spaced because it was both the quarter of my period and my horizontal distance. Again, when I go to graph them, remember 0 is not one of my points, and I'm starting at 135. which is 2. 270 is 6. 405 is 2. 540 is -2. 675 is 2. And again, I'm going to have that space right here without the graph. It would really continue in that direction, right? But again, I want to focus on one cycle being shifted over. So I don't want to kind of put that there. I want to show the fact that it's moved over. All right, so here's another one. Y equals 1/2 cosine of 2x minus 40 degrees minus 3 in degrees. So our amplitude is 1/2. Our period is 180. And again, that's 360 divided by 2, which is my B. I have a vertical displacement of -3 and a horizontal displacement of 20. So again, that's -C over B. So -C is 40 over 2 gives me my 20 degrees. So my before shift values, again, start at 0, and then I want 1/4 of my period. So that's 45 degrees, and then 90, 135, 180 degrees, sorry. And then my after shift values, I'm going to add 20 degrees to each of these. And I forgot the degree symbol on that first one, so it should be 20 degrees. 65 degrees, 110 degrees, 155 degrees, and 200 degrees. So again, just adding 20 to each of those values. For my y's, I have the fact that my minimum was -1/2, my 0 was 0, my maximum was +1/2, and then I'm going to subtract 3 from each of them. So my new minimum is -3.5, my new 0 is -3, and my new maximum, is -2.5. Okay, it's cosine, so it's going to start at the maximum, so it's going to start at -2.5. And then it's going to go up, it's going to go down. Cosine goes down to what would be my 0, which is -3. Continues going down to my minimum, goes back up, and goes back up. So when I go to graph these, make sure you've got lots of room in the negative numbers here. So I'm going to have my -3, that's a terrible 3. Let's try that again. And then it's going to be very squished in here. Sorry, I keep hitting buttons on the side of my screen by accident. -2.5, -3.5. For my angles, I've got 20 degrees, and 65, 110, 155, 200. And then at 20 degrees, I'm at my maximum, and my middle, my minimum, my middle, my maximum. And then make your cosine curve there. Okay, so let's do one more. -3 sine of pi x plus pi over 2 plus 1 in radians. The amplitude, again, remember it's the absolute value. It's always a positive number, it's a distance. So the amplitude is 3. The period is 2 because it's 2 pi divided by pi, so that's 2. The horizontal displacement is -1/2 or -0.5. All right, so -C over B. So the pi's cancel and we're left with negative. Remember there's an invisible 1 there. So we're left with -1/2. And then the vertical displacement is the +1. So our before shift value is 0, and then 1/4 of my period, so 2 divided by 4 is 1/2, and then 1, 1.5, and then 2. Notice there's no pi's here because of the fact that b had a pi in it. So the pi's ended up canceling, and these are just going to be non-pi values, nice rational or decimal values. So my after shift, I'm going to add negative 0.5, so I'm going to subtract 0.5. So negative 0.5, 0, 0.5, 1.5. For the y's, we have a negative sign, so we're going to keep that in mind. And our values were negative 3, 0, and 3. We're going to add 1 to each of them. So my new values are negative 2, 1, and 4. Sign starts at the 0, so it's going to start at 1, and then it's going to go down because we have negative sign. So 1, down to negative 2, back up to 1, up to our maximum of 4, and then back down to 1. So when I go to graph it, again, I have a negative value, so make sure that's on the left of your axes, your origin there. And then 0 is one of my numbers. And then a half, 1, 1.5, and then we've got a negative 2, which again is kind of in the way of some of my buttons here, so I'm going to bring that up a little. And then 4 is up here, and then we also have our middle, which is 1. So at negative 0.5, we're at 1. At 0, we're at negative 2. So again, 0 is one of our values here, so be careful. And then at 1/2, we are at 1. At 1, we're at 4. And at 1.5, we're at 1 again. So we have this upside down sine function here. All right, so make sure that you read through the book and let me know if you have any questions. Thanks.